This is an amazing question because in this single question, we will be using 4 different theorems like chord-chord power theorem, perpendicular bisector of a chord, Thales' theorem, and Pythagoras' theorem. We have a circle. Now draw this chord. Its length is 13 units. Then draw this line which is perpendicular to this chord. Its length is 6 units. Then draw another line which is perpendicular to this line. Its length is 18 units. Our job is to find the radius of this circle. So can you solve it? Okay, in order to solve this problem, let us draw a line which will be parallel to this line like this. Now this is 13 and this is 18 units. So what will be the length of this piece? Yes, you are right. It will be 18 minus 13 or 5 units, right? Now let us draw this line and complete this chord. And let us label the length of this piece as h. Now, there is a theorem called the perpendicular bisector of a chord theorem which states that a line drawn from the center of a circle to a chord which is perpendicular to the chord will always bisect it or cut the chord into 2 equal halves. So let us draw this perpendicular bisector line from the center of this circle. Using the theorem, both of them will be 13 over 2. Now, since these 2 lines are parallel, and this is a right angle, therefore this length will be equal to this, and thus it will be 13 over 2. Similarly, this will also be 13 over 2, right? Now again, using the perpendicular bisector of a chord theorem on this chord, both these pieces will be of equal length. Therefore, we get 13 over 2 plus h will be equal to this will be 13 over 2 plus 5. Therefore, h equals 5. Let us clear things up. Nice! Now, here starts the real magic. We can now use a theorem called the chord-chord power theorem. Imagine 2 lines crossing inside a circle, making 4 pieces like this. Let us label the sides as A, B, C, and D. The theorem says that if you multiply the lengths of the 2 parts of one chord, or A times B, then it will always be equal to the same multiplication for the other chord, or C times D. Now let us draw a line like this. What will be the length of this piece of the chord? Label it as M. Look at these 4 parts of the chord. We can use the chord-chord power theorem here to get this times this, or 18 times 5 equals this times this, or 6 times M. Therefore, we get M equals 90 over 6 or 15 units. So what will be the length of this chord? It will be 15 plus 6, or 21 units. Again, let us clear things up and remove the unnecessary lines. Great! Now, let us connect these 2 points with each other. See clearly? I have made this line pass through the center of this circle. Do you know why? Here comes another theorem called Thales' theorem, which states that if a triangle is formed inside a circle with one of its sides as the diameter of the circle, then the angle opposite to the diameter is always a right angle, or 90 degrees, which means it will pass through the center of this circle. Now, if we label the radius of this circle as r, then this diameter will be of length 2 times r, right? So, finally, we can use our favorite right triangle theorem here to get 2r whole square equals 13 square plus 21 square. Therefore, 4r square equals 169 plus 441, or 610. Thus, r square equals 610 over 4, which will be 152.5, and therefore r equals the square root of this, which is approximately 12.35 units. And that's it. This is our final answer. If you enjoyed this video, please don't forget to like, share, and subscribe to our channel. So good!